food processing automation sector are running with different types of project tasks, which are postgraduate students and doctoral students selected. We are having a different attachments with the professor scientists who are genuinely required a human resource in 3D printing. I am happy that the participants who are enjoying this training, they will be perfect enough to make their concise frame for future opportunistic services which are available with this NAHEP center. So NAHEP center is always for you to keep interactive, keep work in the domain of global impact, and we will be happy to have our all NAGP team organized different kinds of trainings, workshops, and competitions. I'm really happy today because National Agriculture Higher Education Project, NAHP, which is we have formulated from World Bank, Indian Council of Agriculture Research, and VNMKV to establish this center of excellence. I'm happy to share with you for different kinds of your suggestions which will turn to the new projects and their development. I am really thankful to Dr. R.C. Agrawal, who is the National Director, and National Coordinator, Dr. Prabhat Kumar sir, and Dr. Ashok Dhawan sir, who is the Vice Chancellor of this university, who gave us an opportunity to be a very much good storm for those a present generation who are in need of adopting new technologies for the agriculture field. I congratulate to the organizing secretary, Engineer Khemchand Kapgate, and his all team for engaging such a program, which will be the comfortable zone for their future, who are eager to learn from, work from home and learn from home. So I pay my best wishes. I congratulate to all of you those who are joining, and also thanks to Mr. Dr. Rodagi from Altheim Solutions. And I'm really congratulating to all those participants who are joining and making their thoughts to come into in the future. So thanks to one and all.
Thank you, sir. Thank you for your guidance. Your words always inspires us. Today's chief guest, Mr. Prasad Rodgi, founder director, Altheim Technology, Bangalore. He has founded Altheim in 2001 along with his friend. Altheim is today a technology services company actively working in the engineering and life sciences market in India. Under Rodgi sir's leadership, Altheim becomes a leader not only in the 3D printing but also in complete 3D digitization, enabling their customers ranging from SMEs to large enterprises at the time when technology like 3D printing, additive manufacturing was relatively new. Prasad sir conceptualized, articulated, and implemented in initiatives like printmycad.com, exhibiting 3D printing, custom-in-app adults, etc. During the early part of the last decade, where the notable initiatives endeavors towards the popularized additive manufacturing technologies. In 2014, in less than 4 years, Altheim was recognized amongst the India's top 100 small-scale and medium enterprises, and later followed by another award in 2017 as India's most innovative 3D printing from Frost and Soluvian. So I request Mr. Prasad Rodgi sir, so please enlighten us and give your words on this training.
Good morning, everybody.
Good morning.
Thanks a lot for the generous and quite a lengthy introduction, Mr. Khemchand. And Uh, I was just hearing Dr. Sinde also on his enthusiasm towards adopting technology, different technologies to enhance the productivity. I'm glad to be here, and I wish all the participants very fruitful training in coming days. I mean, you rightly said that we are completely 3D technology people, and we have various technologies. And with the pandemic uh, in picture and increase in use of digital technologies, so these technologies have become prevalent in every field, in some fields which we were not even imagining few years earlier. Today, farmers are facing uh, increasing challenges. There is a deteriorating soil quality. There is a decrease in farming land because of the urbanization and all that. There is also a lot of climate fluctuations, which will make it difficult to, produce the crops they used to produce in the past days. Now, in spite of all these challenges, uh, they need to grow more in a lesser land and in difficult conditions to cater to, say, I think we will be 9 to 10 billion population by 2050. So the challenges are increasing year on year. They are not going away. At the same time, the amount of produce that has to be there has to increase substantially to meet the growing population of the world. Now, unless we adopt to all the latest technologies that are available, that are upcoming, it's not only difficult, it's almost impossible to meet or feed the world hunger to the growing population that we there by 2050. Now, we play a key role here. We have various technologies in life science. Most of our technology, all our technologies are focused on the farming and produce side. Quite often we are asked what are we in distribution or supply chain management. We are not there, and my focus is not on that as well. So among primarily on the agricultural side, we do, I would like to classify three primary domains or disciplines that we can address or we tend to address. The first is the bioinformatics. Second is the digital farming or smart agriculture. And third being our farm mechanization. Okay. So like Dr. Sinte said, this is also interdisciplinary, all of them need to go hand in hand together. Looking at the first point, your bioinformatics or agri-bioinformatics, there are a lot of things that we do. We help our customers do, and quite a few agricultural universities are our customers. So the technologies here like Discovery Studio and all will help you in many aspects. They help you to enable plant to handle more biotic and abiotic stresses. Okay. They also, help in understanding the plant pathology and microbiology. This is basically for the agri students who are into research and stuff like that. They help you in analyzing and how you can increase the shelf life of fruits or vegetables so that it reaches the end consumer much faster. End consumer in a good condition without being spoiled and all that. So there are various aspects that we do in bioinformatics. This also includes, nutritional management, micro and macronutritional management, understanding crop and soil dynamics. Then it can also include more effective agrochemical design for better efficacy. So the tools that we have, like from the buyer suite, like Discovery Studio or Pipeline Pilot, help you in doing that. The Pipeline Pilot also help in will also enable you to do a lot of machine learning, build the database, say for example, image processing or many of certain aspects. So these are, and also next gen sequencing, if you want to do anything on genome sequencing, gene editing and all that kind of stuff. So we have life science tools, which helps you primarily in the bioinformatics side. The second point is on the smart agriculture or the digital agriculture. So here we enable with our tools many things. This is primarily where the all the sensors and IoT gadgets are used primarily for optimal nutritional management, whether it is irrigation or fertigation. All the IoT devices that are implemented will help you in achieving that, and will save a lot of cost as well as resources, the resource optimization. One of the challenges the farmers are also facing is that lesser availability of the water. Okay, so in these conditions, if you implement smart irrigation, you'll be able to save 30 to 40% of water that is required, or grow those much more crops in the same amount of water available. So these technologies can be used for all your irrigation methods, whether it is, say, flood irrigation, sprinkler irrigation, drip irrigation. Okay, smart technologies, smart agriculture also includes use of robots, drones. Okay, all this kind of latest stuff. Now, like Dr. Sinde said, these are all interdisciplinary. A drone used in a smart irrigation domain, besides doing the normal things like maybe a fertigation or seeding, can also capture a lot of images of the farm, and your image processing tools in your life science can analyze those images for various things. They can analyze those for weed growth or health of the crops, then enabling you to take a right decision or on what kind of agrochemicals or when the agrochemicals has to be used. They can also even, looking at the image, if the image is of high resolution, they can even, the image processing tools can even give a pH values. What's the soil pH value? So those kind of bioinformatic tools that we have, wherein with the images available, you can take some decisions, you can analyze some things very quick. Now, this is interdisciplinary. You are using drone and you are helping your bioinformatics tools to, take better decisions and do the image processing and many more things. The last part is what we deal in is farm mechanization. So in farm mechanization, as you know, we have host of tools and many customers here, 3D printing, 3D scanning, and many more tools. CAD design, reverse engineering software, reverse engineering tools, and all that. Primarily meant for agri-engineering, not only agri-engineering, meant for agri-engineering students, but in this interdisciplinary world, I think everyone can utilize them. The farm mechanization, generally, the agri equipments and all that you see, which comes from Europe or America, are meant for larger holdings, larger land holdings. And if you are able to digitize these tools, you'll be able to re-engineer that and make it suitable for our smaller holdings, smaller agri lands and smaller agri holdings. Not only that, when you come across, again, the interdisciplinary, when you come across the modern tools like drones and all, today drones are manufactured either by composite materials or by 3D printing. Okay, so you can manufacture drones, you can produce drones using 3D printers and 3D scanning technologies. Now, if you already have a drones, now the mounting devices, whether you want to mount a camera to the drone, or whether you want to mount something which will spray pesticides, all all that mounting devices can be 3D printed. I mean, there is no end to this automation and making everything in-house at one place, integrating different technologies. So those are the aspects that you can cover using 3D printer and 3D scanning. Also, quite often, when it comes to IoT, we think of smart devices, we think of brand new smart devices, but many times you end up converting existing devices into smart devices. You have a non-smart or a dumb device which you have to convert to a smart device. I'll give you an example which is not related to agri. I mean, if there is a cricket bat, which is a dumb device, I mean, it's existing from 200 years, and you want to convert that with a chip inside and make it a coaching cricket bat. We did a project like this, and camouflage that chip and they take all the data on the mobile. I mean, whether the batsman had middled, whether the backlift was correct, and whether the shot was good, how was the sound, whether it hit with the meat of the bat, all that statistics you can capture. Now, if you have to camouflage your sensor into the cricket bat, you need a CAD model of the bat. Now, for a startup or some new enthusiast company, no bad company is going to give the CAD data, and God knows whether they had a CAD data or not. So you end up digitizing. You buy a cricket bat in the market, scan it, you have a digitized model, then create a notch on that, put your sensor in that, camouflage that. Okay, so it's easy to convert. Also, whenever you decide to convert your existing devices to smart devices, 3D scanners and 3D printers play a very, very important role here. You can even imagine a remote control, old remote control, you want to make it a voice enabled or some new, one chip you want to add and do that. So you always need a design data for that, and no Samsung or anybody is going to give you a CAD data. So you end up scanning that, digitizing that, and converting that into the CAD model. So I also told you that a 3D printer can even make drone, and you can even make a robot. You can make an end of the arm tool with a robot and all that. So while many technologies, I mean, like robotics, drone, along with machine learning, AI, and 3D printing, these are all emerging technologies. These are our emerging technologies for the next decade. But 3D printing has a special place in this. 3D printing is not only the emerging technology, it is also the enabler for other emerging technologies like drones or robots or many more things, even AR, VR, we can speak of and all that. So I think I've taken more time than allotted, I think. I mean, with this, I wish you all the best. And since it's such an important thing, 3D printing and 3D scanning, I want you to put your heart and soul, the trainees, and learn that you have best trainers around here. And all the best to you. Thank you.
Thank you, sir, for your informative guidance on the agricultural field and how 3D printers and scanners are very important in the agricultural field, as this is the new domain to our students, PG students and the faculties. Thank you, sir. And now I request Dr. Hemant Rokde, co-organizing secretary, for the vote of thanks.
Good afternoon. A warm and graceful afternoon.
Hello, am I audible? A warm and graceful afternoon to our most valued honorable chief guest, Director, Ultimate Technology, Mr. Prasad Rodagi, PA and PI Nahib, Dr. Jeev Shinde, and everyone gathered here for the inaugural function of online training. It's my privilege to propose a vote of thanks speech and acknowledge the contribution of those who work really hard to organize this training. On behalf of NHAP CAST DFSRDA Parbani, I extend a really heart vote of thanks to our chief guest, Mr. Prasad Rodgi, Director, Ultimate Technology Private Limited, who spared the time for his busiest schedule to grace the occasion. Today, we had the opportunity to hear the thoughts, and this will surely be going to encourage us in our future events. I also thankful to Chairman of our program, Dr. Jeev Shinde, sir, for gracing this occasion and guide us. My sincere thanks to our Honorable Vice Chancellor, sir, Dr. A.S. Dhawan, sir, for their encouragement and continuous support for organizing this training. I would like to thank DI and Dean, Dr. Gokhale sir, for guiding us. I would like to thank to our speaker, Engineer Saksham Rastogi, Application Engineer, Additive Manufacturing at Ultim Technology Private Limited, and Engineer Lakshmikant Sharma, Application Engineer at Ultim Technology Private Limited, for taking the responsibility of enhancing the knowledge of our participant. I would like to express the big thanks to our organizing committee, our Agri Board division, for their continuous effort toward the training organization. Last but not least, I would like to thank all participants for the participation of 2-week training and their presence during the inaugural function. I am thankful to all NHP staff members who directly or indirectly support to organizing the training. Thank you.
Thank you, Rokade sir, for your vote of thanks. Now, with the permission of chair, I declare that inaugural function is over, and we will begin with the today's session. So the today's session is given by Mr. Saksham Rastogi, is a 3D printing specialist working with Ultim Technologies India. He has experience of the both popular 3DP technology as well as mainstream 3D printing application. He provides well-structured training and workshops for students and professionals on additive manufacturing. His prior experience associated with Indian Institute of Technology, Roorkee. He was serving as a technical officer in the Thinkering Lab and taking care of 3D printing lab along with CNC, VMC, Bio 3D printers and industrial 3D scanners. So I request Mr. Saksham Rodgi, Application Engineer, Ultim Technologies, to begin with his session. I also declare that inaugural session is over, and we will going to the technical session with Mr. Saksham Rodgi sir. Saksham Rodgi sir, please.
Thank you all, and all the best to everyone.
Thank you, sir. Thank you for joining.
I'll be logging out.
Good afternoon, everyone, all the participants, and special thanks to NAHIP organization, Khemchand sir, Gopal sir.
Hello.
Yeah, sir, can you, sir,
Saksham,
please, can you please assign me as host?
So you are permitted, sir.
Thank you, sir. Good afternoon, everyone, all the participants and NAHIP community, for giving us this platform to share our experiences, our views on the rapid prototyping through additive manufacturing. So this technology has been into the market past 30 years, and it has been adopted by many of the industries globally, and in India also. Many of the organizations, government organizations, defense organizations, even the private organizations from different industries, they have adopted this technology into their current system, which provided them a lot of advantages in terms of the, you can say, the work efficiency, in terms of the manufacturing efficiencies, cost efficiency, time efficiency, and etc. So I will begin with a short introduction, just a short introduction about our organization. So we at Ultim Technologies, we are allianced with many of the organization providing a complete PLM cycle management systems. So like for the design softwares, we are associated with Dassault Systems. For simulations, we are associated with MSC softwares. For 3D printing in India, we are associated with Stratasys. For 3D scanner, we are associated with Artec 3D. For life sciences, simulations and softwares for drug discovery, drug discoveries, and for the material developments, we are associated with BioVia. For 3D bioprinting, which gives us the capability to do the cell culture, tissue culture in 3D platform, we are associated with Cell Link Life Sciences company. So since the beginning of this organization, we have associated and supported many of the organizations into the country, into the different segments. Like for educations, we have associated with the Nylon, Jadavpur University, NIT Delhi, IIT Delhi, IIT Bombay, CTTC, VIT, and now VNMKV for the NAHEP. For the NAHEP's new segments into the agriculture with the definition of the digital farming solutions, where you can use a 3D printing and 3D scanner to make new projects and to make new products which can help the farmers and the farming technology in the easiest way. Then in the aero and defense, automotive, healthcare, IT services, consumer products, OEMs, like OEMs from automotives and other industries. So also from the agriculture industry, if we look upon, we have associated and supported companies like John Deere, Chrysler, Taffy, VST tillers tractor. So we have associated and supported tractor companies who make the agriculture equipments, farming equipments, and many of the product developments which they do to support the farming technology, agriculture technology in India and global. So let's understand what is 3D printing and what is additive manufacturing. So 3D printing is a process, okay, where you manufacture the part layer by layer, by addition of layer by layer, and you get the final output in a 3D physical data, where you use a 3D digital data in the CAD format. You convert the CAD format into number of slices through a software, slicing software, and then you transport that slicing layers into the machine, which creates a model by addition of layers, and you get a 3D object. So if we compare with our conventional technologies, which was subtractive manufacturing. So in subtractive manufacturing, you take a material, you take a block, and you cut down the material, okay, to get a final shape. But with that final shape, you also get a lot of wastage also. But in the condition of additive manufacturing, in the case of additive manufacturing, you start with the raw material in any form, in any form, like in solid, liquid, or in powder form, and you take that raw material. The machine will will melt the material, or it will cure the material in such a way that it will generate a 3D object by addition of the layers, and the wastage of the materials will be very, very less in compared to of subtractive manufacturing. So that was the 3D printing process. But now what is additive manufacturing? So in the market, there is a very dilemma of what is 3D printing or what is additive manufacturing, and most of the people they combine both of the terms together, but it is not like that. 3D printing is a part of a additive manufacturing process. So additive manufacturing is a very broad term, okay, which includes a work process from design to your final part. So in different industries, you have to take care, you have to take point of the design optimizations, you have to take point of the simulations and pre-processing, pre-preparation before you 3D print your final object. Okay, so the work process starts from your design, your basic design. So design you can make in any CAD software like AutoCAD, NX, CATIA, Pro-E, and then you have to optimize those designs as per the technology which you are going to use for 3D printing. So there are various 3D printing technologies available into the market, and every technology has its design methodology which you have to follow to get a successful output out of the machine. So when you optimize your designs, you have to take care of those design guidelines, and when your design is final, you can simulate those designs in towards of the forces or the heating or the warpage which will be affecting your 3D printing process, okay, during the process, so that this simulation process in through the software, it can save your time and material and cost for the failures of the 3D printing object. So in simulation, when you have pre-processed your designs, when you have optimized your designs as per the technology you are using, then you can proceed with your 3D printing process. And after the completion of your object, you have to post-process. So for post-processing, in the case of the post-processing, you have to remove the support structures. You can improve the surface finish. You can apply some different post-processing techniques on it. You can add some material. You can insert some screws. You can insert some screw inserts. You can put inside of the object during the post-processing, and then you can get the final part which can be used as an end-use part for your product. Like you can make a drone wing, a drone electronic closures for the robots, for the drones, for the AGVs. You can make the wheels, and also you can make any 3D physical object, okay, which is feasible as per the technology you're going to use. So I'm just going to show a short video.
How would you like to have a machine make anything you want? Good, doesn't it? Well, this is now possible the magic of 3D printers. While you might not yet see 3D printers alongside because we'll start to see more and more places in shops, in hospitals, many places. But what is a 3D printer, and how does 3D printing allow us to make the most of anything for nothing? First, take a step back and look at how we normally make stuff. Basically, there are 4 ways. The first is
Sir, audio is not audible, sir.
Hello, sorry.
Sir, आवाज येत नव्हता, sir.
Audio is not clear for the video, sir.
Okay.
Sir, please start from starting, sir.
Okay. Is it audible now?
No, sir. No, sir. Audio is not audible, sir. Sir, is not audible, sir. Hello, sir. Hello.
Hello. Yes, sir.
Sir, audio is not audible, sir. Fully silent, sir.
Yes. He is managing the audio. How it will
Okay,
get
okay.
rectified.
Okay, sir. Okay.
Audio is not. It's not audible at all.
No, sir.
Yes,
It's
sir.
not clear. As the speed of the video is too fast, it's not recognizing to the participants.
How would you like to have a machine that could make anything?
Now it is okay.
Yes,
Okay, sir.
I
Okay.
think.
You want? Fantastic. Well, this is
Hmm? Saksham sir, audio is not there. Can you explain it? Just play the video in background and explain it.
Okay. So this video tells you about the different types of the manufacturing methods that are into the market. So this 3D printing technology can be seen into various places like hospitals, colleges, industries, organization, in R&D, agriculture, farming, everywhere. So these are the four methods to make any object. So first way is the subtractive manufacturing. So in subtractive manufacturing, what do? You take a block of a material, okay, like you take a block of wood, you cut that wood into a definite shape, okay, where you get a lot of wastage and then you get a final output. The second way is the forming. So forming is like you make a clay pot kind of objects, okay, so that is one of the kind of the forming method. The third one is a casting method, okay, where you take a molten material or a molten material of for plastic or metal, and you so in this additive manufacturing, you make the object by addition of layers by layer. So the merging of layers one over the another, it forms a 3D object as the output. So it starts from a CAD drawing, which you make on the software on the computer, and then you send that file to the 3D printer, which slices that file and makes the object by depositing the material in a molten form, and addition of those layers makes the object. So 3D printing helps people to make new kind of objects for new product developments, whether for the plastics, for the material, for the metals, for the ceramics, or any kind of the material. So 3D printing has an application in the industries of aerospace, automotive, agriculture, healthcare, IT, consumer industries. You can make the prosthetics with the 3D printing. Even in the food industry, it can be used. For the medical implants, and with the bio 3D printing, you can make a ear on it or an organ with the patient's tissue by merging the or by the process of the tissue culture or tissue engineering. You can make a working or a live organ using of bio 3D printing. So why this 3D printing is an emerging technology in the industry? So we know that there are many technologies under the umbrella of Industry 4.0 globally. So there are many technologies in the umbrella like IoT, augmented reality, virtual reality, blockchain technology, robots, drones, and 3D printing and artificial intelligence. So these are the emerging technologies that we see nowadays. If we look around, uh, even into our observation, so we see the objects which are related to the blockchain technologies like the cryptocurrency, IoT, Internet of Things, which through which we can make the smart devices or automation devices. Augmented reality, it can be seen for the industrial people, for the engineers. Virtual reality, which can be used for the simulations for the engineering industry or for the healthcare industry. Robots, which can be used on the smart automation industries or into the fields to enhance the capability and to enhance the actions for any kind of the process. Drones, which can be used to present at a specific geographical area without compromising the human efforts, and also saving a lot of life and the money on that. So 3D printing itself, just a minute. So additive manufacturing is providing a potential backbone to various technologies and industries. So with a single 3D printer, you can provide support, you can do activities for the IoT and smart devices, for the development of objects or tooling aids in the smart factories. Okay, for new product development and for new design developments for the drones, which can be used into many fields. For smart medical devices, okay, which can help out for the healthcare industry by different means, through the software, through the IoT medical devices, or through the medical implants, or uh, uh, through the simulated organs, which can be used for the pre-preparation of before the surgeries. In the automotive and engineering industry, where it can be used for new product developments, for the manufacturing floor, for the assembly floor. Aerospace and space industry, where they do not make up mass manufacture parts, they just need a limited number of parts, like for the cabin, like for the aerospace cabin parts, uh, for the cockpit parts, for the fuel tanks. Even the turbines nowadays are making through the 3D printing technology. So the jet engines, its turbines also are now being 3D printed, and they are now being installed and being used as an end use part on the aircraft, whether it's for the commercial aircraft or for the jet engines, for the fighting planes, or for the fighter planes. Even for the space industry, space industries like ISRO, NASA, and many of uh, uh, other organizations who provides the support of for manufacturing for the space industry, they are using the 3D printing technology, okay, to make various kinds of objects into different shapes. Okay, so they get the design freedom and also the material freedom, whether in plastics or in the metal. In healthcare industry also, it can be used in a very vast manner. So in India, healthcare industry is booming very fast now. Many of the organization, hospitals, educational institutions, they are adapting the 3D printing technology in and the consumer industries. So why the industry is moving towards the additive? So first of all, since the time of the COVID era, many of the industries are suffering through the supply chain issues. So many industries which have the manufacturing setups outside India, or who are importing the objects from outside India, okay, they are facing a lot of issues for the supply chain globally. So if an organization is set up in India and they have a office a global office, say in Europe, in US, or in China, or any part of the world, the supply chain has become an issue for them. So many of the industries are now adapting for this purpose also, that they can store the designs in the virtual formats, in the computer hard drives, in the computer systems, and they can print those parts anytime that they want. So this is also called a just-in-time manufacturing, okay, where you can store the data into the digital format, okay, and this additive manufacturing is supporting the concept of the just-in-time manufacturing by uh, by storing the data, by storing the files, design files in the digital format, okay, which will also not consume a lot of physical storage areas and the cost of maintenance of it. And this helps also for the design freedom. So with the subtractive manufacturing, it is very hard to achieve when it comes to make part with very complex objects, okay, which have a very complex shapes to make through the subtractive manufacturing. While in additive, since it's a process where the object is made through the addition of layers, so this gives the design freedom to the engineers, to the people, to the users, okay, to make new products, to make the parts with much more ease than the subtractive manufacturing. So it's a very easy process to make an object, okay. It's just like your 2D printer, okay, where you just give a print command and it gives the output on a piece of paper. Just instead of in a 2D format, you are getting in a 3D format. And also this 3D printing process is giving a complexity free process, okay, where you had to make a cutting tools or the injection molding tools or the die casting tools to make a final object, while it is removing all those heavy and heavy cost making processes with a single click and a single process. So let's see now the popular additive manufacturing technologies which are being used into the industry and which have been adapted by many of the industries for most of their processes to make the final parts. So first technology is the fused deposition modeling. So this is uh, a very worldwide used technology, and it is a very common technology to be used for the 3D printing technology. So in this technology, it uses a thermoplastic material which comes in the form of a filament or a wire, and it heats that material into a semi-liquid state. This semi-liquid material, it extrudes through the nozzle, and through the computer control tool paths, it builds the parts layer by layer. So you get a very hard plastics, hard and rigid and with a very good strength polymer parts through the fused deposition modeling process. The second one is the Polyjet modeling, Polyjet technology, which uses a photopolymeric resin. Okay, this UV curable photopolymeric resin, it jets through a series of the very small nozzles, and this material, it drops down at the base, and a UV light, it cures the material simultaneously, okay, which allows it to cure at the same platform, okay, which also emits the post-processing method for the curing of the final part. This process, it can take multi materials, means it can mix up of 7 materials at a time, and also you can make multicolor parts for complete product realism. So in the automotive industry, in consumer industry, in healthcare industry, it has been used a lot. Even in the engineering industry, it can be used for the tooling aids, like for the jigs and fixtures or for the injection molding processes, and also for the product developments where you require the over molding parts. Then we have third category, which is stereolithography. So in this technology, it uses a liquid curable resin. Okay. Now instead of like in polyjet technology, you use a UV bulb to cure the material. In this technology, the resin material, it stores in a tank. Okay, and the laser, it runs on the material, which forms the shape of a 3D printing of a 3D form object. So in with this process, it is a very faster process also comparatively, and also it can give a very smooth finishing. The objective of using this technology is mainly for when you require a very good aesthetic part or for the casting process. So you can make the objects, okay, with which have a very small wall thickness, or which where you require a very good surface finish, or for the casting processes or for the tooling applications. Then we have a new another technology, which is the binder jetting. So in this technology, the material, the raw material, is used in the form of the powder, in the powder form. The print head of the machine, it jets a binding material, okay, which binds the powder granules of the material, okay, layer by layer, and it forms your final object like this. Okay, so with this technology, you can make the parts which has a very fine details or very small wall thicknesses, small objects, or for the batch manufacturing also. So I'm going to show you some demonstration videos. I think the audio is not visible through the video here. So I'll just try to communicate it with you wherever it is possible.
In a word, it's a game.
So this is the FDM technology, where you get industrial thermoplastics to be used. So there are two nozzles in the form. So what it does, the material, it comes in the wire form, and that was melted in a state as per the using like APC material, which has a different melting points. So one nozzle is support material and one nozzle is model material. So after making of the object, you can post process the part. You can remove the support material. It's a washable support material, and the CAD file is sliced into number of layers. So this is how an object is being created through FDM technology. The FDM materials that you get are very high performance and engineering thermograde plastics here.
Develop the technology to fit a full breadth of geometries.
This is the Polyjet technology. So you can see droplets of the liquid material drops from the very small object jets, and this liquid material, it drops on the build volume. on the build bed, and the UV bulb on the sides, it cures the material simultaneously, and this is how it forms the object layer by layer. So this technology is very useful when it comes to make your multi-material parts or multicolor parts for the engineering industry or healthcare industry, or even for the manufacturing industry. The next technology is the SLA technology, stereolithography. So in this technology, it uses the laser to cure the liquid curable material.
That we don't even know what it is. And when those people believe it, they can do magic, pure magic.
So that was the SLA technology, and now it is the binder jetting technology. So Stratasys has come up with the new machine, which has a technology related to the binder jetting. So this is a video demonstration of it.
Accurate production grade parts with best-in-class consistency, print after print. Introducing the Stratasys H350. Manufacture consistent, functional parts at volume. Meet tough industry standards with industrial-grade components and superior quality materials. Powered by SAF technology with its unique thermal management and patented big wave powder deposition, the H350 provides part consistency build to build. Reproduce part qualities time after time, even on fine feature details and previously hard to print flat areas. Improve the quality assurance of your production with the flexibility to customize your workflow. Access powder management and build data to tailor part qualities to exact specifications. Modify your production process to suit your business, and even begin to explore certified applications for your parts. Reduce costs, not quality. Leverage the H350's high nesting density. Reuse unfused powder without compromising your next build. And lower your cost per part. Industrial grade print heads don't need frequent replacement, so you can maximize uptime whilst minimizing running costs. Plus, accurately predict fluid usage and avoid any unexpected costs. Predict spend and print your parts your way. Choose your workflow, grow your business, and stay competitive with the Stratasys H350.
So these technologies has been into the market, has been invented year by year. So the first technology, the fused deposition technology, through where the 3D printing has started into the market. So it was invented in 1989 and patented in 1992 by Stratasys. So the early adopters of these technologies in India, if we talk about the Indian market, the early adopters were many of the government organizations like the Indian Institute of Science, Indian Institute of Technology, Bombay, GTRE in Bangalore, DRDO organization. So with the upcoming years, many of the different organizations has adapted this technology as a primitive tool for the rapid prototyping and also to be used on the manufacturing floor or as the end use part. So with the global push since the 2005, many of the automotive industries and the agriculture industry like John Deere or the tractor making companies, they are using 3D printing technology to make the prototypes, to make the patterns for casting, to be used on the manufacturing floor for as a jigs and fixtures. So the major adoption has been done by many of these industries, not only into the government organizations, but also into the education industries, in the automotive, tractor making companies, agriculture equipment making companies, construction equipment companies, consumer industry, industrial design, engineers, healthcare industries. So a brief history about the Stratasys which we represent in India is it was invented. This technology was invented by Scott Crumb, and the company Stratasys was founded by him. He patented this technology in 1989 and sold its first 3D printer in 1992. So since then, the technology and the machine design, the machine methodology has been improved a lot as per the scenario and as per the demands of the market leaders, global leaders for the additive manufacturing. So the Stratasys has started its first office from US, and now in 2021 they have 31 global offices. So in India, their headquarters is in Bangalore, and they have 1 lakh plus installations all over the globe, and more than 1400 plus patents with their technology like FDM, Polyjet, binder jetting, and SLA. So why industries are investing into the Stratasys, like in the education sector or in the automotive, aerospace, healthcare, agriculture? So why this industry invest in Stratasys? So the purpose, the prime objective of adopting the 3D printing is to cut down the challenges, okay, which the people are facing through the traditional prototyping process or the conventional subtractive manufacturing process, and also to reduce the time and cost and also the efforts of making the useful parts. So this 3D printing is a tool-less and the labor-less manufacturing process, okay, where you can make the parts by just making a CAD design on the software, and the user doesn't have to think or make the efforts for manufacturing or to find out the suitable manufacturing method to make a part or to make the batch of the parts through the conventional technology. So this 3D printing technology, it provides the repeatability, reliability, and the geometrical freedom when it comes to making of the parts for the end use or for the prototyping. So what are the market trends that we are seeing into the manufacturing nowadays is that many of the industry covers up through this technology. So major of the technologies are the aerospace, automotive, and medical industries, which covers up 51% of the 3D printing market. And apart from that, other industries like the instrumentation, consumer, information and communication technologies, energy systems, environmental technologies, healthcare, chemicals industry, food industry, electronics, automation industries, process control industry. So these industries also contribute when it comes to the consumption of the 3D printing technology. And even the jobs has been emerged out into this category, into this additive manufacturing industry. So not only in global, if we talk about globally with the countries like the US, with the countries in Europe, like in Germany, France, in UK, in Asia also, if we talk about in China, Japan, Dubai, uh, in the UAE. So many of the industries are adapting this technology, and also many of the organization has emerged out to provide the support, to provide the aid to these industries. And because of this, many of the jobs has been emerged out into this category of the additive manufacturing or 3D printing. So the scenario of the manufacturing is changing very fast. Okay, it started with the industrial revolution. Okay, where they use the water and the steam power. Okay, for the mechanical production. Then it moves towards a mass production when the automotive industry booms up, and they make the labor division and the assembly lines, which requires a very high manufacturing domain knowledge. Now, in the towards coming the 21st century, it moved towards the use of the robots on the manufacturing line by using of the production automation, electronics, and the IT, which required the skills for the mechatronics, CNC, computer skills. But now, towards now, from the 2020 or from the past 5 years, this industry 4.0 has been used into the manufacturing domain or for the product development domain, where it uses the IoT enabled devices or to set up a smart manufacturing methodology. Okay, which require the skills of the 3D printing, IoT devices, mechatronics again, and the good manufacturing domain knowledge. So in a nutshell, the market trend of the additive manufacturing is very interesting, which covers up many of the markets in different categories, and also it is creating the jobs into this industry, which can provide the aid, which can provide the support to the OEMs, to the vendors, to the suppliers, and also to the service industry. So let's see what are the materials available for 3D printing, which makes it more suitable. Okay, when you shift towards the 3D printing technology and through the traditional manufacturing methods. So in this FDM material portfolio, we have the polymers from the standard plastics, engineering plastic, high performance plastics. So with standard plastics, which are very common into the industries like the ABS, PLA. Then we have the engineering plastics, which are very common, like the polycarbonate, nylon, and with the high performance materials, which are very suitable for the aerospace industry. And also they are certified grade materials to be used in the aerospace industry and automotive industry, which are the Ultem 1010, Ultem 9085, PEC-based PPSF material and Tero material, and the composite like the nylon 12 carbon fiber. So these are the super polymers and the engineering polymers which can be used and which has been successful in many of the cases, which has replaced a high grade of the aluminum metals or the stainless steel metals, okay, by using of these super polymers and engineering plastics, engineering polymers using of the for different applications. So let's start with some basic materials. What are these basic materials and what are its capabilities? What are its characteristics? So the ABS, which is a very industrial common thermoplastic material, it is used to make the form and fit prototyping. The Stratasys machine, it is able to provide the soluble support material. Okay, so you get a very good dimensional stability, you get a very good geometrical freedom, which makes it much more suitable material for the any kind of the industry. Then we have the ASA material. Okay, the ASA is similar, shares the similar mechanical properties to the ABS, and additionally it is a UV stable material. So in the condition where you want a part to be used in the outdoor condition under the direct sunlight, you can use this ASA material, okay, which is a UV stable, which helps it to be which helps it not to deform under the UV conditions, under the thermal conditions in the outdoor areas and direct exposure to sunlight, and it maintains its dimensional stability over the time, and it gives a very good semi-matte surface finish also. So many of the industry, they use ASA material for the prototyping for the end use parts when it comes to be used in the outdoor conditions. Then we have a thermoplastic an elastomer material, okay, which has been just recently launched by the Stratasys. It's a thermoplastic urethane material which has a shore hardness of 92A and an elongation break of 500%. So that means you can make the hoses, bell halos, and any kind of the part which requires elastomeric properties. And this material also comes with the soluble supports, which helps to maintain its geometrical freedom and dimensional stabilities. Then we have a composite polycarbonate ABS, okay, which has both of the properties of PC and ABS with high strength and high heat and impact resistance. So this part can be used to make the enclosures or the body parts, BIW parts, which can provide a very good strength and also a good heat and impact resistance. Okay, so you can make the parts for the robots. You can make the body parts for the AGVs, robots, and the drones by using this material, where you require high strength and also a high heat and impact resistance for the manufacturing of that part. Then we have a Diran material, which is a mineral filled nylon 12 material. Okay, it's a very strong and the flexible material, and it is designed to be used generally for the on the manufacturing floor to make the jigs, fixtures of the manufacturing aids. But it also provides you very good mechanical and thermal properties. So a condition, an application where you require a strong but a lightweight part, okay, and also a very good, a very high wear resistance into that part, you can use this material for that condition. Then we have the ABS HD7 material, okay, which is a electrostatic dissipative material. So the advantage of using this material is to store the electronic component. So when you're making a robot or an AGV or a drone, and you are making the enclosures for your electronic components for your PCBs, okay, instead of using a metal enclosure, you can use this ABS EST7 material, okay, which protects the sensitivity of the electronics, which protects a static dissipation of the electronic parts, and it will give more life to your PCB parts, storing with this material enclosures. Now coming up towards the engineering and high performance FDM materials. So first we have a polycarbonate material. So polycarbonate is also a very common material. You might have heard and you might have seen a lot of parts, lot of objects around you. The key properties which this material provides, it's a good impact resistance, durability, and also heat resistance. It can be used for manufacturing applications like for the metal forming tools or as a end use parts. So you can see in the photo that this base is a tool, is a forming tool, which is made up of using the polycarbonate material, 3D printed polycarbonate material, and it can be used to make the sheet metal parts, okay, through the forming application. Then we have the elastomer material. So it's there is a very good demand of the elastomer materials in the market, into the industry, where you require a key properties of a high elongation property, good tear strength, and a good fire resistant property. This can be used for the applications to make the bellows, hoses, seals, and the trims. Then we have a very super polymer material, which is a Ultem 9085, which is a FAA approved, which is the Aerospace Authority of US, which provides a certification to the materials which can be used and as the end use part into the aerospace or into the aircrafts. So this material has been FAA approved by the US Aerospace Authority, and it provides key properties with a good tensile strength, with a good torsional strength, and it is also FST certified. So FST means it is fire resistance, smoke resistance, and toxic resistance. So it provides resistance to various toxic materials. So an example that it can be used to make the drones, UAVs. It can be used to make the flight parts. It can be used to make a fire-prone objects, also a fire-prone parts also, where you can use in the condition to make for the parts of robots, AGVs, and the drones. Then we have a composite material, nylon 12 carbon fiber. So nylon carbon fiber is a 35% reinforced weight by weight ratio. So that means the carbon fiber is mixed in the chalk form with a 35% weight to weight ratio with nylon 12 material. So this material, it provides a very good fatigue property, a very good stiffness to weight ratio, and a very good chemical resistance. This material can be used to make the lightweight tooling parts or the lightweight end use parts. So an application or a condition where you want a lightweight part, but with the very good strength, a very good strength to weight ratio, you can use this nylon 12 carbon fiber material. Then we have another FAA approved material, which is the Ultem 1010 material. So this material also shares the same key properties, but also it can be used to make the composite tooling molds. It can be used to make the flight parts. It can be used to make the fuel tanks, or the condition where there's a impact of high heat during the operations. So it can be made to make the AC vents. It can be used to make the fuel tanks. It can be used to make the various cockpit parts directly, and it can be used as an end use parts in the aircraft. Then we have a polyether ketone based material, which is the Antero material. So the key properties which it shares is the good chemical resistivity, a good temperature resistance, and a very ultra low outgassing. So that means you can use in a condition where the various toxic gases are going to impact on the polymer. Okay, so if you have some application where some toxic gases can impact the enclosure or the storage of that material or the storage of that part, okay, you can use this material, Antero material, okay, which is highly non-reactive to many of the toxic gases. So you can use this to make the clean room tooling. You can use it for space production parts. You can also use it for the chemical contact parts. So these are some of the key properties. These are some of the key mechanical properties which the Stratasys materials provides, which makes it much more suitable and much more reliable when it comes to the high performance or the heavy engineering applications, like in the automotive, aerospace, to make the UAV, drones, robots, or parts with the lightweight but with a very good strength ratio, parts with the good chemical resistivity or good thermal resistivity. So the ultimate intent material, it can it can provide a thermal resistance of up to 210 degrees Celsius, which is more suitable material when it comes to the thermoforming applications, uh, uh, or in a condition where you require a very good heat resistance or thermal resistance. So these polymers, these basic engineering and the high performance polymers which are developed by the Stratasys, which are tuned by the Stratasys research and development teams, they have been approved, and also there has been many case studies which we will share further, which I will show you further in the upcoming days, that how these materials has provided a very good application for different industries, how these materials can be used for different cases, for different parts, which you can make, so that you can get an idea when you are going to make that, when you are going to design your parts, when you are going to manufacture parts through FDM technology, you can choose which material will be much more suitable for that particular application or for that particular case. Then Stratasys also provides the Polyjet technology, and with the Polyjet technology there are 7 categories. There are actually 6 categories of materials. So first is the rigid opaque material. So this rigid opaque material, it shares the similar close to mechanical properties of the ABS or the acrylic material. So it comes in the various color options like the white, black, gray, blue, yellow, cyan, magenta. Then we have the rigid and transparent material, which is the VaroClear material. The VaroClear material, it provides a transparency of around 92%, okay, which is much more closer to the industrial acrylic or industrial glass material, and with a very good yellow index, okay, so that you can make a very much more transparent object which can be simulated as close to the acrylic or the glass material. Then we have the simulated polypropylene material. This material is being useful to make the hinges, living hinges, or the flexible materials, or the parts which require a good strength, a good flexibility also. Then we have the simulated rubber material. The rubber materials which can be mixed with any of the materials you can see in the list, okay, and you can make the different shore hardness rubber values, like from shore 27 to shore 92, so that you can get a different hardness, a different flexibility by mixing the rubber material with any of the rigid opaque rigid transparent, polypropylene, high temperature or high toughness material. Then we have a high temperature material, RGD 515. It is being developed by the Stratasys R&D team, and this material, it can be used in a condition where you want a very high temperature resistance. This can provide a resistance of up to 150 to 160 degrees Celsius, which is much more enough to be used in a very basic cases, like to make the robotic parts or drone parts or the AGV parts. Then we have the high toughness material, which is the digital ABS material. So the combination of RGD 531 and RGD 535, it provides a very unique combination of mechanical property, which provides you a very good strength, a very good rough rigidness to the material, so that you can use to make the parts where you require a good impact resistance also. So these are the materials which comes along for the with the Polyjet technology, and you can make the parts with the multicolor and the multi-material capabilities. So let's see what are the characteristics and the workflow for the fused deposition modeling machine. So we are going to focus much more on this technology because this technology has been adopted globally, and many of the 70 to 80% of the industry globally, and even if I just talk about the Indian market, then 70 to 80% of the Indian market, they use the FDM technology when it comes for their product developments, new product developments, for the rapid prototyping applications, for the manufacturing aids like the jigs and fixtures, or the assembly line on the assembly line floors, for the quality inspection equipments, or as an end use parts. So the Stratasys FDM machine, it provides a very good unique characteristics, and also it has more than 1400 plus patents to its name. So the first very unique characteristics which it provides, and which is very essential also for the FDM technology, is to maintain the inside temperature, okay, in the build volume when the machine is working, when the material is melting into a soft molten stage, and it is being deposited on the build volume and the addition of the layers. So the high temperature build oven chamber it maintains the inside temperature as per the material you are using. So if you are using, suppose, an ABS material to make the prototype or to make the 3D part, this technology will maintain an oven temperature of around 110 degrees Celsius, okay, which is a required ambient temperature for the ABS material. So this high temperature build chamber is required to maintain the inside chamber temperature, so that the materials are ensured to be printed consistently, and also to be fused together with each other. So suppose if you're making a part with a height of 10 centimeter, okay, in 10 centimeter, then if there is no accurate inside temperature, okay, inside the machine, if it is not able to maintain the ambient temperature for that particular material, then you might be able to see the various issues like the warpage or the distortion of the object, and it can damage your part, or it can also damage the nozzles or the print head, okay, during the operation. So this oven chamber, it ensures that your part is built up in a very consistent manner, and also the part which you will, the material which you are printing, okay, the part you are printing, you get it with a very good surface finish and also with a very good dimensional stability. The second one is the separate toggling and self-cleaning tips. So the machine comes with two extruders. One is the model, one is for the model material and another is for the support material. So what happens that separate toggling means that when as per the geometry that you're making, when the model material is active, when the model extruder is active, the support extruder will toggle up, okay, with a very small height, so that it will not interact or it will not crash with the model that you're making. Okay, and similar, it will be used in the condition of the support material. So if support material is active, your model extruder will toggle up, and if the model material is using, then the support extruder will toggle up. And also when the machine is getting prepared, okay, it comes with the self-cleaning tips for the extruder nozzles, so that the extruder automatically cleans up its tips, okay, for any of the extra material that is coming out during the preparation or during the pre-preparation of the machine. The third one is the high temperature self-adhesive build tray. So this build tray, which comes with the machine, it ensures that that your part which you're printing, it sticks up to the build plate, okay, during its entire operation, so that there will be no issues like the warpage or the distortions or the displacement of your model part, okay, of your printing part during the operation. The material cartridges, it comes with the automatic, it comes with the EEP ROM, it comes with the chip, smart chips, which indicates on the control panel that how much material is remaining or how much material is being required for that particular job. So suppose if you're making a geometry and it requires a material of 5 cubic inches or 10 cubic inches, and if the material is not sufficient that time in the material cartridge, okay, it will indicate you on the control panel, okay, on the user interface, that you need to change the material. Or this machine also comes with the two model cartridges, or sorry, two model base, material base and two support base, so that if one model cartridge is going to empty, okay, it will automatically switches to the second cartridge, so that your machine runs up continuously 24/7 without any interruptions and without any baby monitoring. This machine is also ensures a very high life of the machine, okay. So all the motion control components, all the electronic components which needs to be secured from the high temperatures of the build chamber, okay, because of build chamber it can goes up to 240 degrees Celsius, and it can damage a lot to the electronic parts or the motion control components, okay. So all the electronic components or all the motion control components, it is installed outside of the build chamber, and it is thermally isolated also, okay, so that it can provide you a good machine durability and very good high machine life. So many of our users, many of the Stratasys users in India, they are using the machine with more than 10 years. So a single machine which can run with more than 10 years and which they are using continuously. So this kind of the technologies and these kind of the patents the Stratasys has come up with, okay, which makes it very good, which makes this brand and this machine a very reliable, durable and repeatable. So let's see what is the workflow when it comes to the FDM technology. So how do you start with your process, and how do you get your final output? So first of all, you make a 3D CAD design, a 3D design in the CAD software. Okay, you can use any open source software, free software, or the paid license softwares to make a 3D CAD model. And when you're done with your 3D CAD model, you can import that model in the GrabPad print. So this GrabPad print is the software developed by the Stratasys only. So every 3D printer has its own running software. So this GrabPad print is the running or the slicing software for the Stratasys machines. So in this GrabPad print, you can load your CAD model. You can set up your parameters. So what are the parameters? How do you work upon with the software? That we will see in the upcoming time. So the basic workflow is that you load up the model, you set up your orientation, you set up your parameters like the layer thickness, infill density, and also the support density. You can manage your support density also. You can select where you require more dense parts or less dense parts. So, and also you can manage the different infill density at the different sections of a particular part. So when you're done with setting up your part, okay, you can give the command to the connected 3D printer. The software will slice up the model, okay, into the number of layers as per the layer thickness you have chosen. These layers are being these layers are being converted into the G codes, and this G codes controls the motion components of the machine. So these motion components, it runs as per the G codes has been converted into the X by Z formats. The model material and the support material, it extrudes the material as per the G codes has been developed for the XYZ coordinates. So once your model is being done through the 3D printing process, you can take out the part through the machine. The support material, which is a dissolvable material, okay, which can be removed very much easy with a very much easy process. It can be insert into an agitation tank, okay, which has a solvent which absorbs or which dissolves the support material, and then you get the final part without any support materials, without any extra material on that particular part, which will save your post-processing time also, and it maintains your dimensional and the geometrical freedom. So there is a video of how the machine looks like, okay, how the workflow for the FDM machine is there. What are the characteristics, what are the different characteristics of the Stratasys FDM machines?
Hello everyone, and welcome to this special early edition of 2-Minute Tuesdays. Today we're excited to reveal the latest innovation in 3D printing, the Stratasys F123 series. The F123 series is a culmination of almost 30 years of Stratasys research and development, encompassing 43 existing patents and 15 brand new ones. It was designed for ease of use, making it accessible to people with little or no 3D printing experience, but versatile enough for advanced users. The F123 series consists of the F170, F270, and F370. These machines offer larger build chambers than past generations, along with 4 different slice heights, faster print speeds, and more materials. Today I'm going to walk you through the F370 here, but everything I mention will hold true on the F170 and F270 unless otherwise noted. For your initial setup, plan only 60 minutes to get the machine up and running. It plugs into a normal grounded outlet and is much quieter than past printers, making it perfect for the office. The printer was built with very careful consideration of components. It features servo motors as opposed to stepper motors and more sensors to read position accurately. The mechanical components are all located outside of the heated chamber, which prevents degradation from prolonged exposure to heat. The system features improved temperature control in the build chamber to nearly eliminate curling and warping of parts. The build tray is more flexible, allowing you to easily remove parts. And as you can see here, it easily snaps in and out of the machine. In terms of material, possibly the most impressive feature, even to printing veterans, is the 2-minute, 30-second material changeover time from hitting unload to beginning to print again. On the F270 and F370, material automatically changes from one cartridge to a secondary cartridge to allow for extended printing. A key complaint in the past was the inability to print at 5/1000ths of an inch and lack of access to materials besides ABS. These issues have been addressed, giving you ASA and PLA in addition to ABS. Furthermore, the 370 gives you access to PC-ABS, which offers more toughness, flexibility, and one of the highest impact resistance of all 3D printed plastics. In terms of the printing process, the F123 series has a newly designed print head, which eliminates the need to change tips. To control aesthetics and minimize issues related to material purging, each printing job automatically has a sacrificial tower. These machines offer a fast draft mode in PLA for inexpensive, quick models. Regarding accuracy testing on the new systems, 45 different parts were printed with varying dimensional requirements, and they were printed on 3 separate machines. The results were 99.9% of parts had accuracy within plus or minus 10/1000ths of an inch on a 5-inch part. The machines use SR35 support material, which dissolves faster than some prior support materials, but most notably, it is much easier to remove by hand. A nice enhancement is the camera, which you can use to remotely check the status of your prints. It also gives you several options for connectivity. The F123 series will all use GrabCAD print software, except the F370, which will also have the option of using the more advanced Insight processing software. GrabCAD Print has an improved intuitive interface, which allows you to more quickly set up and modify your build parameters. It also provides mobile access, making it easier for you to manage prints on the go. Today we covered a lot of detail, but I want to reinforce the bigger picture for these systems. Whether you're a total novice to 3D printing or an industry expert, the Stratasys F123 printers will deliver strong, repeatable, dependable parts that simply have no parallel in the industry. Thanks for joining us for this special edition, and we'll see you next time.
So you have seen that FDM technology. So how the machine looks like, how much it is easy to operate the machine, what are the special characteristics, how much easy to take out the part from the build tray, how easy to remove the support materials out of the final 3D printed part, and the dimensional accuracy, okay, which is achievable because of these patented technologies through the Stratasys, like oven build chamber or the thermal insulations, the build adhesion tray. Okay, the build adhesion tray also plays the role there. So there are many ways. Okay, there are many ways through which the Stratasys FDM technology provides very good dimensional stability and always a very good part and you can make any complex object. The users have all the geometrical freedom by using of the support material, removal support material, so that you can make any kind of the complex object, any kind of the designs which you want to make, okay, which was not possible or which is very much difficult through the subtractive manufacturing or any kind of the conventional manufacturing methods. So also the same process also goes with the Polyjet technology, a similar kind of the process. So with the Polyjet technology, you can make the parts with a very high resolution of 16 microns. I think some, can you please mute your mics, all the participants? So in Polyjet modeling also, you can make the parts with a very high precision and a very high resolution of 16 microns. You get a complete geometrical freedom by using of the soluble supports. You can make the large parts with a bed size of 500 cross 400 cross 200 millimeter. And you get the combinations of the 12 materials, and by using those 12 materials, you can make, by mixing of these 12 materials, you can make combination of more than 10,000 material combinations, okay, which have different mechanical properties, which have different chemical properties, and it can be chosen as per the application that you are going to use. So the process also, the process for the Polyjet also is very much similar. So you make a CAD design, and if you want to apply some aesthetics over the part, so suppose if you are making a part and if you want to apply some part name or some graphics or some images over the surface of the part, and you want to make you want to give it more aesthetic looks to your product. Okay, so after making the design, you can apply those images, or you can apply those renders through the KeyShot, through the CATIA, ADS Max or Maya softwares, and the GraphCAD print is able to import all those native formats. Okay, so now GraphCAD can intake the files directly from the SolidWorks, CATIA, Creo, NX, Inventor, AutoCAD, and also through the KeyShot also. So that there will be no data loss when you are converting your native CAD files into the STL files. So what are those issues which comes, and what are the formats, okay, which are into the industry, that we will see in the tomorrow sessions, where I will show you what are the different file formats, okay, which can be used or which are very popular in the 3D printing industry. What are the issues comes up with those file formats, which are the most usable formats into the industry, which you will find like the STL or the IGS formats or OBJ formats, and how you can use the and what softwares you can use to make your CAD files, or to import or to export the CAD files into the STL formats. What are the softwares for the 3D printing industry, like the NetFab or the Magix, and what are its characteristics, what are its advantages, which provides a much more smoother operation, or which provides many more features which are being used or which are necessary for a particular 3D printing technology. So this is one video of showing how Polyjet modeling process goes.
Once printing is completed, remove the part using a scraper or spatula, taking care not to pry or bend the model. SUP 706 soluble support material can be removed manually with a water jet, in a sodium hydroxide solution, or with a combination of these methods. The method you choose will depend on the size and delicacy of the model and the amount and location of the support material. First, manually remove support material surrounding the model. This step is optional, but will reduce solution soaking time. Another option is a high-pressure water jet. Be careful not to damage delicate models if you choose to clean them with a water jet. Although SUP 706 can be removed with a water jet, its advantage over SUP 705 is that it can be dissolved in a sodium hydroxide solution. SUP 706 reduces time and labor with hands-free support removal, and soluble support allows you to clean delicate parts and internal cavities without the risk of damaging the model with a water jet or cleaning tool. Models printed with soluble support can also be cleaned in batches, saving even more time and labor. To dissolve the support material, use a cleaning tank suitable for a solution of 2% sodium hydroxide and 1% sodium metasilicate. The cleaning tank should have a pump that circulates the solution continuously. To mix the solution, make sure the tank is clean, then add 20 liters of water. Operate the circulation device and slowly pour 400 grams of sodium hydroxide into the tank. Continue mixing the solution until the sodium hydroxide is completely dissolved. Next, add 200 grams of sodium metasilicate to the solution and continue mixing for about 15 minutes. You now have a solution with approximately 2% sodium hydroxide and 1% sodium metasilicate. If you need to fill a larger tank, maintain these proportions. Allow the solution to cool to room temperature and soak the model for 30 minutes to several hours, depending on how delicate the model is and how much support material needs to be removed. Models with walls less than 1 millimeter thick may deform slightly if soaked for more than 1 hour. Over time, SUP 706 dissolves into the solution, reducing its effectiveness. Replace the solution after approximately 1 month of average use. After soaking, rinse the model thoroughly under running water. To strengthen the model, dip it in a 15% glycerol solution for 30 seconds. Then, set it aside to dry. For more post-processing documents and videos, visit us.
So I'm going to show you some examples globally and from India that has been used to the 3D printing applications. So a 3D printing application has been used by many of the industries, and many of the reports, many of the articles has been published through which many of the organization has achieved many of the tasks, many of the activities through the 3D printing industry, which 3D printing has provided a much more aid towards the many of the institution and organizations in terms of development of new parts, in terms of development of new types of technology to easy or import of parts to the outside countries. So like for the aerospace industries where or the UAVs or the drones where you want to do the wind tunnel testings or the mechanism development or the damage assessment models. Okay, so for that industry 3D printing has been used. RWDI who do the wind tunnel testings and the structural testings of the tall buildings or the tall monuments. So RWDI is a US based organization and they have a setup in India also in the south region where they have the facility to test up the structures or the monuments, tall monuments or the tall structures. Okay, so they make the miniatures of it. They make the miniature scaled down models, and they set up the models with the same geographical or the mimic the geographical conditions into that testing areas, and they put and install the sensors into the object. So this object which you are seeing here, which is a miniature of the Statue of Unity. So this part has been 3D printed, the complete whole part with a scaled down model, and the sensors has been installed inside the part, okay, which detects various readings, okay, as per the wind is running around this 3D printed object or around this object, which gives the readings to the engineers so that they can optimize its movements or they can optimize its the orientation of the object or the orientation of the building as per the geographical conditions. To the NASA, ISRO, HAL, who are using this 3D printing technology to make a final end use parts or to make the prototypes or to make the functional prototypes to mimic the conditions of the space, to make the prototypes which can be used as a demonstration models or to as a testing models, okay, for their developments, for their research. And also there has been articles published. There are the applications where a 3D printed part, a polymer 3D printed part from the Stratasys machine has been installed on the satellites. Okay, satellites for the so there is one example from the NASA who has printed the 30 antenna arrays to be used as an end use or to be installed as an end use part on the satellite to be used in the space. So you can see that the materials which are provided through the Stratasys machine not only being useful for the prototyping application, but it can be used as an end use part for the high performance areas where you require high strength, high chemical resistance, high thermal resistance in the conditions of the space, into the space industry, into the aircraft industry, into the wind tunnel testings, or to make the high strength part with a lightweight ratio. So there are many of the examples there which we will discuss further in this workshop. So what does this 3D printing makes it to work? Okay, so with this 3D printing, you can pre-manufacture the part. Pre-manufacture the part means you can make the prototypes, you can make the functional prototypes before actual going to the production. So if there is a condition, if there is an application where you want to make or where the metal is the only choice to make, okay, but you cannot prototype, you cannot spend that much amount of money, you cannot spend that much of the efforts just to make a new product or to make new prototypes with the metal material. Okay, in that condition, you can use the polymers, okay, high performance polymers or the engineering polymers, and you can make the functional prototypes to check its form and fit, and its functional testing also you can do, so that you can do the successful replications, you can do the design iterations without spending lot of efforts and the time, which will save your product development or the research time also and efforts also. Second is you can use it as the end use parts, okay, which will give you much more design creativity and a very less design constraints when it comes to the 3D printing, by making the object through the 3D printing technology. So you can optimize your designs, okay, you can cut down the material consumption, okay. So you can see in the design, in the first design, that if you make a part through the conventional manufacturing process, the design would be like this, and through the 3D printing technology, you can optimize your design, okay. So in the additive manufacturing process, which I've shown you in the starting of the presentation, where you make the design and then you customize those designs, optimize those designs as per the necessity, as per the application, okay. So as per the necessity, wherever the material is required, so you can cut down the materials, okay, as per the design optimizations, and you can do the simulation of those designs in the software, so that you can see where the thermal or the impact load will be there on the end use part, so that you can do the necessary design iterations on the product. It goes for the polymer and for the metal parts, both of them. So with the 3D printing technology, you can make the pre-manufacturing parts and the end use parts, okay, which proves to be a successful adoption of this technology into the various industries. So I conclude with this note that 3D printing is a very unique and the upcoming and emerging technology. And in India, it has a lot of scope in many of the industries. So earlier it was adopted only through the automotive or the aerospace industries, but now many of the market leaders, many of the industrial leaders, researchers, scientists, they are much more focusing on to use this technology into different segments of medical, healthcare, farming, agriculture. Any application where you can ease up your process, any application where you can ease up your design process, your manufacturing process, where you want to reduce your lead time of manufacturing, cost of manufacturing, and also you want to achieve some design freedom. You want to reduce your design constraints because of the limitation of the manufacturing available into the market, or the complexity manufacturing because of those designs. So 3D printing is a very unique tool, a very unique manufacturing process which can help out everyone. Okay, you just have to make the design. So the process is very simple. You make the design, you choose your machine, you choose your technology, your material, and the machine will provide you the as a end use part. So thank you very much for today. Thank you all the participants for being the good listener. And if there is any question, you can please ask me.
Hello. Any participant having a question, please type in your chat box or directly ask to the sir. Hello. I think participant having no question. So I declare that the today's session will be closed here, and tomorrow we will meet in, as per the scheduled time. Thank you, sir.
Thank you, sir. Thank you, everyone. Thank you, all the participants. Have a good one.